In this video, I will be explaining what oxidation numbers are. This represents the beginning of oxidation reduction reactions, but I will be talking more about these reactions in following videos. So, oxidation number. An oxidation number tells you the number of electrons lost, gained, or shared as a result of a chemical bond. So, in other words, the change in the oxidation state or number of a compound will tell you if it got oxidized or reduced. But again, I'll be talking more about oxidation and reduction in following videos. This one is just about how to determine the oxidation number of a compound, of an atom in a compound. So there are some rules that you have to know about oxidation numbers that will always apply. The first one is that the oxidation number of an element will always be 0. So element will always be 0. So something like silver in its elemental form, so it's a solid, will have an oxidation number of 0. And this also applies for diatomic elements. So let's go with chlorine. Its oxidation number, this is a gas, will be 0 as well. So don't get tricked by diatomic elements. As long as an element is in its natural form or its elemental form, it'll have an oxidation number of 0. If you have a polyatomic ion or a monatomic ion, so pretty much an ion, its oxidation number will be equal to its charge. So oxidation number will be equal to charge. So an example of this would be the same chlorine but with a negative. So it's a chlorine ion. The oxidation number is equal to -1. So because the charge is a minus here. And if you have something like NO3, it's a polyatomic ion, and it has a minus here too, you'll have an oxidation number of -1 as well. Now, another rule is that the oxidation number for oxygen in a compound will always be -2. So oxygen in compound has an oxidation number of -2. So something like water, H2O, oxygen will have just the oxygen will have an oxidation number of -2. The hydrogen would be something different. For hydrogens, if a hydrogen is not bonded, is not in a chemical bond with a metal, it will have an oxidation number of +1. So for hydrogen, oxidation number will be +1, except when in a compound with metals. Because then it would have to be a negative charge. So it would be, its oxidation number would be -1. Let me fix this. -1. So actually, let's try the H2O. So because this compound, the whole molecule of water, doesn't have a charge, it means that its oxidation number will be equal to 0. So what you have to do to determine the oxidation number of a compound or a molecule is just separated into a kind of equation. So for water, we don't really have to do that because we know the oxidation number for hydrogen and oxygen. It would be, for in this case, hydrogen is bonded to oxygen and it's not a metal, so it'll have an oxidation number of +1. That is for hydrogen, and then the oxygen has a -2. So let's put a plus here. So +1 plus -2, but we have 2 hydrogens, so we multiply this part by 2. This is a plus. So, and we know this has to be equal to 0, just because the molecule doesn't have a charge. So I mean, if you do it, 2 minus 2 is equal to 0. So the oxidation numbers are right. And I forgot to mention, there's one more rule that will always apply. Fluorine will always have an oxidation number of -1. So F will always have an oxidation number of -1. Of course, except in its elemental form, diatomic, it would be 0. But whenever in a compound, it will have an oxidation number of -1. So this is constant. And this doesn't change due to its electronegativity. So when it's in a bond with like chlorine, it makes the chlorine positive. But we'll talk more about that as we get to electronegativity. Now let's try some practice. Let's try something like carbon dioxide, CO2. First of all, we see that there is no charge, which means that in our equation this will be equal to 0. Then we have to identify what we have and what we don't have. What we don't have, we'll assign an x to it. So the carbon, we don't know the value of the oxidation number, so we'll say it's x, plus we know that the oxidation number of oxygen is -2, and we have 2 atoms of oxygen, so you multiply that by 2. So what we get is that x minus 4 will be equal to 0, so x will be equal to +4. So now we know that the oxidation number for carbon is +4. So carbon oxidation number will be equal to +4. Now let's try something with a charge. So SO4 2 minus, or -2, it's the same. So the first thing we have to know is that this is an ion, a polyatomic ion. So this will be equal to the charge. In this case is -2. We have to identify which we don't have. In this case is the sulfur. So we put x to it. And plus, we know that the oxygen will be -2. And we have 4. So you multiply this by 4. Now we have x is equal to -8. X minus 8 is equal to -2, sorry. And we get that sulfur has a oxidation number of +6. So sulfur, an oxidation number of +6. These values are not constant, so this will change depending on the compound. So just because the carbon in this case has a +4, the sulfur has a +6, doesn't mean that you'll always have a +6. You always have to determine it. The only values that we have constant are the oxygen and the hydrogen, and the fluorine. So that is how you determine the oxidation number of an element or an atom in a compound.